Hello students. So now let's start the 8051 serial port. So in this we will discuss about basics of serial communication. So here two types of communications are there: parallel communication and serial communication. Parallel, as often 8 or more lines are used to transfer data to a device that is only a few feet away, and means on board. Whenever we need on board communication, then we can use the parallel communication. When we need to we can if we want to use the long distance communication, then we can use the serial communication. So basically we need the serial transfer, then in that case sender and receivers are over there, and these senders and receivers can send the data. In parallel transfer you have D0 to D7, and parallelly we can send the data. So in this case bit by bit we can send the data. In this case we can directly send the data in at one time. So definitely parallel communication is more faster than that of serial communication, but at the cost of the space which at distance for which we can communicate it. So there are more two things: one is synchronous and another is asynchronous. So there is synchronous method, transfer of a block of data at a time, and asynchronous method to send a single byte. So there are special ICs for that purpose. One is UART, Universal Asynchronous Receiver Transmitter, and another is USART, means so it is Universal Synchronous Asynchronous Receiver Transmitter. Asynchronous start or stop bit. Asynchronous serial data communication is widely used for character oriented transmission. Each character is placed in between start and stop bits, and this is called framing. Block oriented data transfer use the synchronous methods. The start bit is always 1 bit, but the stop bit can be 1 or 2 bits. The start bit is always 0 low, and the stop bit is always high. So that is a asynchronous communication, and this is the frame of transmitting a data from one side to the another side. There is a space, stop bit 0, D0 to D7. This is the data, and then start bit is also over there. Then there is a mark. When there is no transfer, the signal is 1, which is referred to as mark. So, and when there is a transfer, then start bit it gets low, and when it's low, the receiver understands that some data is about to come. Then the data is transferred, and then a stop bit comes, and then a space is there. Then again mark will start from the another cases. So the data rate is in serial data communication is started in BPS, or bits per seconds. So another widely used terminology for BPS is Baud rate. Baud rate is also BPS is also bits per second is also known as Baud rate, and it is a modern terminology, and it is defined as number of signals changes per seconds. So there are occasion when a single change of a signal transfers several bits of the data, and as far as the conductor wire is concerned, the Baud rate and BPS are same. Okay, so means transmitter and receiver both must be at same Baud rate, so that communication can happen easily. Okay, so this is about the 8051 serial port. It is synchronous and asynchronous. SCON register is used to control and data transfer through TXD and RXD pins. Sometimes clock through TXD pins is over there. 4 modes of operations are over there. Mode 0 synchronous serial communication. Mode 1 8-bit UART with timer data rate, 9-bit UART data rate, and mode 3 is for 9-bit UART with timer data rate. So these 3 registers are important: SBUF register, serial buffer register, SCON register, and PCON register. So serial control register and PCON register can define the data. SBUF can have the data to transmit or receive, and it has the TXD line. It must be placed in the SBUF register. The moment a byte is written into the SBUF is if it is framed with the start and stop bits and transferred serially via the TXD line. SBUF holds the byte of the data when it is received by 8051 RxD line. When the bits are received serially via RxD, the 8051 deframes it by eliminating the stop and start bits, making a byte out of the data received and then placing it in the SBUF register. So this is the SCON register. SCON register has SM0, SM1, SM2, receive enable. These bits are over here. Some discrepancy in the picture. RI is here, TI is here, and then RB8 is here. I will correct it and send you again. So this is the serial control, and it is SM0 and SM1. So there are 4 modes. 8-bit shift register is used, 8-bit UART is used, 9-bit and 9-bit UART is used over there. In this, enable multiprocessor communication mode. In this is the receive enable and enable the data, set to enable the serial data reception. Then TB8 is there. TB8 is used to 9th data bit sent in the 2 and 3 mode. And next is the RB8, 9th data bit to be received when it is in the 2 and 3 mode. TI and RI are the interrupts, and it is set when the stop bit is transmitted, and set when the character is received, receive interrupt. So 8051 serial port mode 0, and here you can find this that serial data enters and exits through RxD. TXD outputs the clock. 8 bits are transmitted and received. The baud rate is fixed at 1/12 of the clock oscillator frequency. So serial data enters through RxD, serial data exits through TXD. On receive, the stop bit goes into RB8 in SCON, and 10 bits are transmitted or received. Start bit, there it says only 0 bit is to transmit, 8 bit of the data, and 1 bit is to stop bit, is the stop bit. And baud rate is need to be decided by the timers. So this is the serial mode 2. So 9 bits are there, okay, for the data. In mode 3 there are also 9 bits, and 11 bits are transmitted in that case. So this is how the we can program the serial controller. So T mode register is loaded with the value 20H, indicating the use of the timer in 1, and mode 2 8-bit auto reload to set the baud rate. TH1 is loaded with the one of the values to set the baud rate for the serial transfer. SCON register is loaded with the value 50H, okay, indicating the serial mode 1, where an 8-bit data is framed with the start and stop bit. TR1 is set to 1 to start timer 1. TI is cleared when by CLR TI instruction. The character byte is to be transferred serially to return into the SBUF register. TI flag bit is monitored with the use of the instruction JNB TI XX to see if the character has been transferred completely. To transfer the next byte, go to step 5. So that's how we can program the serial data transmission. So it is the programming of the serial data reception. So when we need to receive the any byte, then we need to follow these steps actually, okay. So now this is the doubling the baud rate, so that's we can do by the peak on register. So there is a S mode register, GF1, GF0, PD and ideal. So if we need to if we need to double this baud rate, so we can get it high, S mode can be get it high, and then the rate will be doubled. So these are some of the baud rate which we need to follow, and we need to use this terminology for the powering the providing the data into the timers and registers. So here we need to put the value -3, -6, -12 and -12, 24, and here is the hexadecimal values, and this is the baud rate which we can get at this using this 8051 UART. So in the next lecture we will discuss about 8051 interrupts. Thank you.